Hi, welcome to Math with Miss Aker. Today we're starting a new topic, geometry. And for Just Know It, we're going to review some terms that we're going to use today during our lesson. But before we get started with that, let's just know where we can see some of these things in nature. So I have a couple pictures here I want to share with you. The first one is a starfish. So take a look at that and think about where in that image you can see some sort of symmetry, or maybe you see some angles or lines going in different directions. Where are the points of the starfish? And think about this one as you do try it later, because that might be a clue. Here's a leaf, and on that leaf you can see there are some lines drawn that make different angles, and you can just see all those different areas of the leaf. And then this one's really interesting. This is a spider working on its web, and you can see there is an angle here, two lines extending, or two rays extending in each direction. And then you can see all the intricate details here. So geometry is often found in nature, and we need to know geometry for a lot of different jobs and things that we do in this world. So let's look at some of our words. An exact location in space with no length or width, that would be a point. Part of a line has one endpoint and continues on in one direction. So there's a point, continues on, that would be called a ray. And I think of that one with sun rays. Part of a line has two endpoints and includes all the points between those two endpoints. So that's called a segment or a line segment, because it's a part of that line. A collection of points going on infinitely in both directions. Well, that would just be a line. So a segment is just the part between those 2 points, but the line goes on and on. And then two rays that have a common endpoint, that would be an angle. And this could be turned any which way, just like we saw when we were looking at our geometry in nature. So let's, for Figure It Out today, identify some of these and even take a pass at drawing them. Okay, so this says to identify each figure. So for number 1, let's take a look up here. What could this be? So there's two endpoints and it stops here. So yeah, we would know that this is a segment. Okay, for number 2, we have 2 points here and then it goes on in both directions. Do you know it? Well, that would be a line. Not a line segment, but a line. Okay, down here, this one's a little hard to see. Let's tilt it down a bit. So this one, did you guess it? Yeah, that one, that's a point. So it's just a point. It has no width or height, or it's just, or no length, so it's just there in space. And this one says to draw a ray CD, and sometimes we can identify a ray by putting that symbol over top of it. So we can just pick 2 points. Okay, I'm gonna label it C, D. I can connect those and that becomes a segment. Now if I drew an arrow going this way and an arrow going that way, that would be a line. I need to just make a ray. So if I imagine it just going off in one direction. Great job with Figure It Out. All right, for what's new, we have a new learning target here today. Whoopsie. I can draw and identify lines, rays, segments, and parallel, perpendicular, and intersecting lines. So we know we're gonna be doing some drawing. I'm just drawing a figure there. Identify means, you know, we can name it, we can identify with our eyes. So we know lines go in both directions. Rays go in one direction, and segments stop at 2 endpoints. And now parallel, perpendicular, and intersecting. Let's take a look at that. So I have some examples of that. So parallel are 2 lines that go in the same direction in both directions and never once cross or touch. Intersecting lines are going to cross at one point, and it's not going to make a perfect right angle. And perpendicular lines are going to cross at one point as well, but they're going to make a perfect right angle, so perfectly up and down and vertical, okay? Vertical and horizontal. So let's take a look at how we can do our identification and drawing of lines, segments, and rays in our What's New problems today. Grab your writing tool and some paper or a marker board, and let's get started. So keeping in mind what we learned today from our learning target and during Just Know It and Figure It Out, we are going to use this graphic to the right to find the following. So we're going to name 4 points. Okay, so I see A, B, C, D. I also see E and F, so there's actually 6. Name 4 lines. So remember, lines go off, they're not segments. They go off in either direction. So let's see if we can do that. Okay, so I see AD, line AD. I see DF, line DF. I see line CF. And let's see. Now, we've done here and here and here. Now what I'm noticing is there are some segments. So I'm going to do a segment section, a line segment. Now we could do CA. So AC is a line segment. And then we have DF is, if we just go from here to here, that would be a line segment. So we can make it a line that goes in either direction, or we can stop at those 2 points. And there's some more of those like B and E. So we have lots of options there. Nice job. Okay, name 2 rays. So we're going to be starting at an end point and going in one direction. So I'm going to say CF. So going from C to F. And let's do ED. Okay, and there are lots more rays we could do. Okay, now it says name 2 pairs of parallel lines. I remember parallel because of it says those L's help me remember. So let's see. I see AC is parallel to DF. So we can say AC, line AC, is parallel to DF. Are there any more? Let's see. We could say AD is parallel to CF. All right, nice job with that. Name 2 pairs of perpendicular. So that's going to be ones that make a perfect right angle. So we have AD is perpendicular to DE. And then we have EF is perpendicular to FC. Nice job. Okay, this says use the dot matrix to draw the following, line AC. So let's just AC. Okay, check. Segment AB. Here we go. Angle ABD. Okay, so we need a D, point D. So there's our angle, ABD, ABD. Line EF parallel to line AC. So we need an E and a F parallel. Okay, we could come up here. I'm gonna make that EF. So now those run parallel. And then segment EG perpendicular to EF. So EG is gonna be perpendicular. So we need to bring a line down here. Let's go like this. Oh, whoops, I made a mistake because we have to go through E. So pretend that's not there. So we have to, let's relabel this E over here. You know what? I think we should move this over. Let's move this over down here so we have more space. So we're still making it perpendicular. Okay, so we have E. We have point, so we can have E here. and F here. And now E, G, perpendicular. So there we go. So now we can go through here. So let's make this G. And now it's perpendicular right there. All right. Yeah, sometimes when you're doing these and drawing your own, you might need to rearrange it a little bit so you can fit it a little bit better as you're labeling. Thanks for doing some geometry with me today during What's New. It's time for Try It. Now, this one today says, what figure is formed inside this polygon if all the possible line segments are drawn to connect the 5 points shown? So think about if you connected all of these points together every which way, what polygon would you make? Could be kind of interesting. Can't wait to see what you do with that. It is time to say goodbye. Let's end with a clickety-clackety roller coaster, firework, and then another roller coaster. Here we go. Clickety, clackety, clickety, clackety, clickety, clackety, wee, wee, wee. Shh. Ha. Clickety, clackety, clickety, clackety, clickety, clackety, wee, wee, wee. Thank you for watching.